Okay, so let's try to think of something loopy off the top of my head.
While loops?
Let's try to maybe do something related to prime numbers.
For loops?
How about the user
Your screen.
enters...
Your screen. Your screen's not showing.
Wrong screen. Sorry, thank you.
Yeah, let's say like, I'm just guessing.
Yeah, I had to push the other button. So they put an icon here that looks like a computer, so I think, oh, I'm supposed to push that button to get the computer to show up. But then it's the other one. In the other classroom I teach in, it's the opposite, so go figure. Yeah, so let's say in this fictitious assignment, the user enters a number, and our job is to determine if any numbers divide evenly. If so, print them.
Oh, was that the last assignment? No, that was the coding exercise. Okay, sure.
Yeah, if this was our coding application, I wouldn't be doing this because then I would be giving you the answer. So this should expressly not be what your assignment is. And if so, then I'm going to feel kind of silly.
Just very similar to the coding exercise.
No, that's good, because I want it to be relevant to what you're trying to do on your own outside of class. That's the reason why I'm doing it, so excellent to hear. Okay, so for this, we're going to do the pseudocode, then the flowchart, then the Python, right? Easy enough that we can get done fairly quickly, complicated enough that it gives you a reasonable example of how to do some kind of a loop, right? And if we want to, we can make it fancier by saying, keep asking for more numbers until a user says to stop. So we can put an outer loop on it. As we've learned, we can basically put an outer loop on any of the problems we've been doing. So we'll just do that again to make it interesting. Okay, so pseudocode. We know we want a begin, we know we want an end, and in between here we need to fill in with some stuff. So I have to figure out how I'm going to solve this problem a little bit, but I can discern from this the inputs, the processing steps, and the outputs. So the user enters a number. That's a pretty good indication that I'm going to need to get a number from the user. Okay? Determine if any numbers divide evenly into that number. You might think that you can just say, determine if any ... Okay, no, that's not good enough. It's good enough at a high level, but it's not good enough for, we need to drill down because now we're doing loops, and so we need to actually use some kind of repetitive logic in our pseudocode to prove to somebody that we know how to do the assignment. So instead of just determine if there are any, we need to loop to check if any numbers, blah, blah, blah. I'm going to run out of room here on the screen. And inside the loop, we're going to say if number divides evenly
by 2.
Print it. And this is pseudocode, not Python, so we're going to say this is the end of our loop.
Okay.
Just to make it clear. And then, we can go back and say, start outer loop, ask user if they are done, if so, stop looping, and outer loop. So if you turn in something like this, again, I didn't put more detail here because I don't have very much space here on the screen, but using a reasonable font on your computer, I would expect you to do a little bit more. Same with the flowchart here. I'll show you how to do the flowchart. Let's forget the outer loop for the first cut. I'm going to declare a variable. What do we want to call this variable?
Bananas.
And I want it to be something representative of what it's going to be used for, but I'm trying to figure out a one-word description of what it's going to be used for.
Compute. Repeat.
How about factory? We're going to factor it. We're going to figure out if there's any integers that are factors of this number. So we'll call it factory.
Very good.
You know, as opposed to factory, we're going to call it factory. And we can make it an integer, that's fine. So I'll do an input. So we'll get a value for that. Now, if we're going to look for numbers that divide evenly into factory, we're basically going to have to use a calculation that says if factory divided by this number has a zero remainder, or if it divides evenly, then we want to print it, right? Yeah.
Modulus?
That's a good thing to do. See, in the old days, when I was a youngster like yourselves, back when I had to walk to school uphill in the snow both directions, we had to do something like if the integer of factory divided by the number equals the factory divided by the number, well, because we knew one would have a decimal and the other wouldn't, because we're truncating the decimal, and we'd say if those two values are equal, then it divides evenly. That works, right? But then you have to do, you're basically doing division twice, and the modulus is a lot more CPU efficient way to do the same thing. Essentially, in the modulus, you're asking if the remainder is zero, right, is what we're going to do. So here we can refine this a little bit. Loop over numbers from 1 to the number. If number loop index from 1 to the number. If number modulus index divides evenly, which means that equals 0, right?
Oh, remainder, right?
Then we print the index, because that's our number. So that's basically what we want to do. So that's where it's kind of a little bit chicken and egg thing. You're doing your pseudocode to get a high-level outline or rough draft of what your program's going to be, but you do have to do a little bit of analysis there. It's perfectly okay to do the pseudocode like we did and leave some of it a little fudgy, and then go over and do your Python and say, oh, now I figured out how I'm going to actually solve that. You can come over here and refine it a little bit. Again, we don't want to get programming over here, but you want to be clear enough that you could give this algorithm to somebody else and they could run with it. They wouldn't have to figure out a bunch of stuff. But this is pretty close to what I need to do for the pseudocode for this problem. Okay, and now that I know that, I can do the flowchart. So I've got my number, and now I need a loop. So I'm going to need another variable. Let's call it index, since I already came up with that other one. So down here, I have while loops, for loops, and do loops under the looping column. Ooh, what's over here? Look at all that. Cool.
I used the for loop.
Okay, but if I'm going to do a while loop, I'll do the while loop because that's the, okay, I'll just let you know. Anytime you do a for loop, it's implemented with a while loop.
Wait, it's implemented with a while loop?
Yeah, anything that you can do with a for loop, you can implement with a while loop.
Okay.
But the vast majority of things that you can implement with a while loop, you can't implement with a for loop because it's not that kind of loop. This one is. Anytime you're counting from one to some upper limit, a for loop is perfectly appropriate. That's a perfect tool for the job.
Okay.
But when you're saying while true, like our outer loop often says, or while the temperature hasn't reached 90 degrees yet, or any number of thousands of different expressions that you could imagine that you could use in a while loop, none of those can be implemented as for loops. So it's kind of a special pattern, and it's shorthand for the longer version, so I'm just going to do the while version. Okay, so I'm going to do an assignment. Every loop has 3 components. You set the initial condition to 1 in this case. So we've set the initial condition. Then you test that condition. So while index is less than or equal to number, factor E. And then somewhere inside the loop, unless you want it to be an infinite loop, you have to modify the loop condition. And I say that very specifically. You have to modify the loop condition. I didn't say you have to modify factor E. I didn't say you have to modify index. I didn't say time passes. No. Whatever you use as your loop condition, you have to have the potential of that condition changing while your loop is executing. If it can't change, you have an infinite loop. So in this case, I use 2 variables in my loop condition. So one of those variables is going to have to change value. And as we know how we're supposed to implement this, I basically want to add 1 to index. That's how I'm going to modify the loop condition. So in here, I'm going to need an assign statement. Index is index plus 1. That's how I add 1 to index. Does that make sense?
Yeah.
So if I do nothing else, what this flowchart will do is it'll ask you to enter a number. Let's say you enter 4. Then this loop is going to count 1, 2, 3, 4, and then it's going to exit. Yeah, it's not very useful, but that's fine. We're not done yet. But those are the 3 components of a loop. You set the initial condition, you check the condition, and you modify the condition. Every loop has to have those 3 things. Again, unless you intend for it to be a infinite loop. Okay, so now I'm looping, I got that part done. So now inside here somewhere I need to ask, is this a factor of that value? If so, print it. So now the only question, should I put the box up here above the add one to index, or should I put it below the add one to index?
I think it's below.
Any other thoughts?
I think it's up.
Up? So why do you say one or the other? And it's good to think about this because this is a very common source of errors, logical errors in your program.
I would think like you have to have that first, so it will have like its foundation, then you go to the next step. So that's why I said down.
Okay, fair enough.
Like we haven't used the original of the index value is 1, so we have to use 1 first, and then we go.
That's an excellent point. I set the starting point to 1, but I haven't used it yet. So if I add 1 to it, I've skipped 1 and now I'm starting with 2. Right?
Okay.
I could fix that by setting index to 0, and then the first time through the loop, add 1 to it. Now I'm starting with 1 again, right?
Okay.
So it really, you could do it either way, depending on what your assumptions are. But what you can't do is mismatch it. You can't start index at 0 and then put your code above it. You can't set it to 1 and put your code below it. You can start it with 1 and put your code above it, that's a match. You can start it at 0 and put your code below it, that's a match, but you can't do it the other ways, okay? So it just has to match. And otherwise, that causes what we call an off by 1 error in your program. Logically, it'll work either way, but you just have to do it the correct way. So since I started at 1, we'll go ahead and put the code up here above it. Now, if I just said output index, then if I run it, 5. Then it just counts from 1 to 5, right?
Yeah.
But, you know, this is one of those iterative illustrations where I can put a little bit of functionality in and test my program, put a little bit more, test my program. What this shows me is my loop is working, right? I didn't do anything, it didn't count to 1,000,000 and I had to close it. No, stop, right? I don't have an infinite loop, but I know that's not right yet. So I'm going to delete that output. So this specifically says if number modulus index is equal to 0, then print. So that's what I need to replicate here. So inside here, I'm going to add my conditional if, what is it, factory modulus index equals 0. And so if that's true, then I want to print index.
And if it's not true, you just...
Not true, but I don't do anything.
Okay.
I could put something in there if I wanted to, but the assignment doesn't need to do anything. Okay, let's see what that does. Let's say 12. So this prints 1. Yeah, 1 divides into everything. 2, yeah, 2 divides into 12. 3 divides into 12. 4, 6, and 12. So it looks like it worked. Let's try something else.
21.
21. 1, 3, 7, and 21. So it looks like it's working. Okay, so now I know my flowchart works. So now let's go do the Python.
I think the worst at the flowchart.
Yeah, it can be finicky. Okay, don't have to declare, but I do have to put my comments. It says, teacher, COP 1000, factors of a number. Okay, get a fact, what? Get factory value factory equals int input
Index.
please enter a number. See if it has factors. So now's where I do my loop. I can say index equals 1 while index is less than or equal to factory. Have to indent if factory mod index is 0, print f factor of f is and then this is the tricky bit that you'll probably forget at least once in your career. Index equals index plus 1. Or you'll forget and you'll unindent it, right? What does this do?
It gets it out of the loop.
Yeah, it adds 1 to index, but it never gets there because this is an infinite loop and it just stays inside that loop forever, right? So yeah, we want to make sure we indent that. And
But shouldn't it be next to print, though? The index equals.
well, okay, what does that do? If I do that, what happens?
It adds it to the print.
But these two statements only execute if this is true.
Oh.
Notice over here in the flowchart, the index equals index plus 1 is after the if statement.
Okay.
I love it that you guys are seeing this because you will make that mistake. So it makes sense to think about what the outcome is of doing this. But no, that's where we want it. Whether the number that we're testing is a factor or not, we always want to add 1 to the index. And then, down here at the bottom, we'll probably print thank you, right? Let's test that before we do the outer loop. Let's test that and see if it works. How about a prime number? Does anybody know a prime number?
3.
It cannot be divided with any other input.
Yeah, tell me one.
3.
Well, 3 is kind of small, but I'll use that. So yeah, 1 and 3 are the only ones that factor into it, so it's a prime number. What about a higher one?
5?
Higher.
71.
71 you think is a prime? Let's see. Yeah, 71 is prime because only 1 and 71 divide into it.
Okay. How about
33? No.
Well, let's see. Let's try it. Why think about it?
yeah, no, it's not.
No, if it's not, 3 and 11 go into it.
How about
11.
11.
112?
No.
112 is even, so that's,
Like
No.
113.
but see, we've created a program that now will tell us, yeah, 113 is prime. Okay, so let's play with this a little bit. First, we want to add the outer loop, right? And as we know, if we can do something without the outer loop, we've done all of this code, we can do this multiple times. All we have to do is basically indent it and surround it with the outer loop logic, right? So up here, we'll say while true, And then down here we'll say, go again equals input. Do you want another number? And if go again equals no,
Return.
break. That's a more structured way to do it. I've seen some people using sys.exit. I don't like that. That's a non-graceful exit to your program. I just don't like it as well as a pattern. Yeah, so break just breaks it out of this outer loop. So now it should keep doing it. This is not my favorite pattern because break isn't even as structured. Break is basically the same thing as the go to. I really prefer the go again equals true while go again
Equals true.
and then now it's just a standard loop. I set my loop condition, I tested my loop condition, now I have to modify my loop condition. So I don't even need this down here. Because this is modifying my loop condition, so when it comes back around to the while, it'll say, nope, I'm done, I don't need to do it again. Well, I have to say,
Yeah, you gotta change it because
while go again is not equal to no, I want to keep looping, right?
yeah.
Let's see if that works. Please enter a number, 17. Do you want another number? Yes. Please enter a number, 42. Ooh, it's got a whole bunch of factors. Do you want another one? No. Booyah. So I really like this pattern. To me, that's structured and elegant. Doesn't use anything fancy, you know, but it's functional. Does the job.
Question, what does apostrophe equal to sign mean?
Not equal to.
Not equal to?
Yeah, in Python that means not equal to.
Alright, okay.
Yeah, some languages, you'll see less than, greater than. It's like, well, if it's not less than and it's not greater than, it must be equal to, right? But in Python, it's exclamation point equals for not equal to.
Okay.
Okay, here's another thing we could say. What if I enter a prime number, and you notice when I run this, let's do 17 again. It says a factor of 17 is 1 and a factor of 17 is 17. But yeah, I know that. That's going to be printed for every number. What if I don't want to print that? What if I only want to print it if there's something other than 1 and the number? What would I need to do to my program to make it do that? Yeah.
You could change it, the index to 2 and then have it be till factory minus 1.
Okay, that's one thing. Or what else could I do if I wanted to leave it 1?
You could have an if statement to see like if the index equals 1 or...
Yeah, like we did on our flowchart. But that would be more code here, so I'm just going to do your first suggestion. So I can set the index to start at 2, so that skips 1. And then, how do I get rid of the 17?
Factory minus 1 on the...
Okay, that's a good suggestion. Factory minus 1. So now I'm stopping 1 earlier. Anything else I could do? What if I just make this less than? Instead of less than or equal to?
Yeah, that one works.
That also does it. That means, you know, it's never going to get quite up to factory. It's going to stop before it gets there.
Yeah.
Okay, let's see if that works. Please enter a number, 17. Yeah, that doesn't print anything. But did I break the other stuff? So let's do another number. What was the one, 42?
Yeah. Okay.
Yeah, it's got a whole bunch still. So it worked for 17 and it worked for 42. So in other words, it worked for a prime and it worked for a non-prime. So that's pretty good testing. What if I don't want all these factors? I just want you to tell me, is it prime? Yes or no?
Then I'm pretty sure you change the print statements to say prime or not prime.
Okay, so I know I don't want to do that print, right?
Yeah.
But the unfortunate thing is with primes, you have to wait until you process all the numbers, right, before you know that it is prime. If you find any number, you know it's not a prime. But you have to wait until you process all the numbers before you know it is a prime. So how about this? How about if we create a variable, is prime,
Yeah.
and we set it to false at the top. And inside here, instead of printing, we found something, we say is prime equals, so now we know it's not a prime.
Wait, shouldn't we start the first one as
Good catch. Dang it. You guys are getting too good. Yeah, so I assume it's prime. I go through the loop, and if I discover, nope, it's not prime, then I'll set this to false. Then, after my loop finishes, I can say if is prime. I can say that, but I don't need to, right?
You could just say is prime actually, right?
I can say if it is prime. Then I say print that is a prime
Number.
else
Print.
that is not a prime number.
But there are prime numbers and there are what numbers?
Not prime. Don't make it too hard.
I'm pretty sure there's another name for like consecutive numbers, I think.
Okay, let's see if that works. Enter a number, 17. That is a prime number. You want another number? Yes. Enter a number, 42. That is not a prime number. You want another? No. So that's looking pretty good, isn't it?
Yeah.
Okay, what else can I do? Okay, one thing that I want to point out to you about this particular problem, you remember when it was printing our factors? Let me put this back in, where we're printing all of the factors. So, 42. And it has a whole bunch of them, right? 2, 3, 6, 7, 14, 21. Well, one of the things that you notice about this is 2 times 21 is 42. 3 times 14 is 42. 6 times 7 is 42. So every one that's listed has a pair that it's matched with, right? Well, then why do I have to loop 6 times? Couldn't I just loop till I get to here? And by the time I get there, I will know whether it's a prime number or not?
Yeah.
I mean, for these little numbers, it doesn't really matter. But what if you're trying to search, test 3 billion and something? Say 3 billion and 1, is that a prime? Right? But that's going to be looping for a long time. So anything I can do to shorten that loop will help. Well, it turns out, if we stop at the square root of the number, that's good enough. We don't have to go any further than that. Let's see if that's true and whether I just lied to you. Enter a number, 42. Yeah, you got me. I have to import math, right?
Okay, I said like, what is math? Line 4.
Oh, no module named math. Wait a minute. Am I having a stroke? What is it? Do I just say square root? What is it in Python?
Oh, that's how you say square root.
Oh, you have it capitalized, the math?
So it's just lowercase math?
Maybe.
Yeah.
But,
And then I guess import math.
so that's how you say square root in Python?
Import math.
If you're gonna put input.
Yeah, you took that out.
Like that?
Yeah, that should be
but-
good. Let's see.
Let's, yeah, try it.
There we go.
Okay.
Yeah, so that looks like, so it did 2, 3, 6, but it didn't do the other 3. So that looks right. So let me comment out this print statement so I don't get 8 zillion of them and run it again. And let's check 3.
1 billion.
It says that is not a prime number.
Wait, I didn't even have to.
Do we trust it? Do you want to see what the factors are? Because all we got to do is uncomment this line, right?
Okay, let's see it.
3, 1, 2, 3.
You don't even remember how many zeros you put. Try it.
Interesting.
Oh.
So 7 times 49? Do I believe that?
That's only 2 numbers, so technically it is prime, but I don't think I believe that. So.
That doesn't feel right.
That doesn't feel
It
right.
says 7 divides evenly and 49 divides evenly.
Like 3 billion.
Wait, divides evenly into the?
Yeah.
That's weird.
3.
Wait, what?
3, 1, 2, 3, 1, 2, 3, 1.
So,
Divided by 47?
No, it's decimal. It's weird.
but it's 49, not 47.
Or 49.
Yeah,
Yeah, what is,
It is even.
apparently it is.
huh,
That's strange.
Do we look at this? What is the square root value of it? Is that like a, because shouldn't it be a bit bigger than 49?
probably is, but it doesn't mean that that's got any more factors. I don't know, it's one of those things where you kind of have to know the answer yourself before you know whether your program's working right. That's a good testing lesson. Know what the expected value is before you, because we're sitting here staring at it and we've got confirmation bias, because we already know that that's what our program output, we just don't know whether it's right or not. So you're going to have to go to some other method, like a calculator or something else, to prove to yourself whether that's correct or not.
Wow.
But I think it is. I don't have any reason to doubt it. But that's caused a lot of software testers to get dinged when they didn't discover a bug using that logic.
Is prime.
Guess you're right. It's not wrong, so.
Okay. Yeah, that was fun. So as far as I know, we successfully created a program that will tell you whether a number is prime or not in a not terribly inefficient way.
But it seems to divide evenly for them, though. That's kind of weird.
Okay?
So, well, tell me the difference between having one multiplication symbol and having 2 together, because I just figured out how to do it, and the only difference was I just put 2 multiplication symbols together than one.
Well, that's a different operator. That's exponent, so it's not multiplication. That's like 2 to the number instead of 2 times the number. Okay, so there you go. There's an example. I mean, I could go back. We fiddled with this a little bit. I could go back and make the pseudocode and the flowchart and the Python all match with our final result. But I think you guys see the gist of it. We successfully did if statements and loops in our program. So you've seen how to do that. One of the things I want you to feel from this is the level of detail that I went to in my pseudocode. Doesn't need to be more. I don't want you doing the Python and then copy and pasting this and saying that's your pseudocode. It should still be in human readable terms, but you don't need to go to this level of detail. But if you just say, instead of putting this in here, if you just say, do the stuff, yeah, then that's not enough detail, okay? So I hope you see the happy medium that I struck there with that example. Okay, any questions before I wrap that up? And I'll post this for your reference.